This video is going to show you how to complete the problems on page 10 of your math book. And what we're supposed to be doing is we're supposed to be given this table, we're supposed to determine whether or not it shows a proportional relationship. So it wants to know if y is proportional to x. Is the cost proportional to the amount of candy in pounds? So the table below shows the relationship between the amount of candy bought in pounds and the total cost of candy in dollars. So it's already labeled as x and y, so you don't have to do that step, but we do have to determine if it is a proportional relationship. So to do that, to find unit rate, that's how we determine if it's proportional. If there's a consistent unit rate, that's what we have to figure out. So I'm drawing an arrow up there so I have room, and we got to go y divided by x. That's $10 for 5 pounds. Okay, that's not the unit rate, that's just a rate right there. So let's go ahead and find that unit rate. Looks like we got to divide by 5, and 10 divided by 5 is $2 a pound. So I took that x value and I multiplied it by 2. Alright, this one right here, y divided by x, it's $8 for 4 pounds. Okay, let's go ahead and find that unit rate. Divide by 4, 8 divided by 4 is 2, yeah, $2 a pound. So again, we multiplied by $2, that x value, to get the corresponding y value. So y divided by x to find the unit rate, $12 for 6 pounds of candy. And that's not the unit rate, that's just a rate. So I had to divide by 6, 12 divided by 6 is $2 a pound. Hey, this is looking like it's probably going to be proportional, but you can't really jump to conclusions. You must check every single one of them, because in one of the previous examples, everything was consistent, but then there was one oddball that made it non-proportional in a previous video. Okay, y divided by x is, okay, so 16 divided by 8, 16 eighths, and its unit rate, divided by 8, 16 divided by 8 is $2 a pound. So we multiplied this by 2. Alright, this last little relationship down here, again, it's y divided by x, $20 for 10 pounds of candy, and it's looking like that unit rate is going to be consistent, because divide by 10, 20 divided by 10 is $2 a pound. Okay, this is a proportional table, okay? So we do have to justify it. So yes, cost is proportional to the amount of candy in pounds, because there's a constant rate, which is another name for unit rate, of $2 per pound. Okay, I do want to take a second and I want to show you what the equation would be that represents this situation, okay? So off to the side, I'm just going to write equation. And do you know what it is? It's y, so that y value is equal to, how do they get the y value? Oh, they just took 2 times all the x values to get the corresponding y value. Okay? Look, it works for everything in the table. So if I was like, what's the y value going to be here? I don't know it. You take 2 times that, boom, and you get this. Okay, if you don't know this one, 2 times that x value is 16. Look, we got that. We got the y value. And again, you can rewrite this as 2x equals y. But I do want you to always label it, because it's going to definitely help you. So this is going to be cost. This x is representing the pounds of candy. And that right there is the unit rate. Okay, look at the next problem, please. Oh, it's another table, but this is a horizontal table. Randy's planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total amount of gallons used. Assume that the number of miles driven is proportional to the number of gallons consumed in order to complete the table. Okay, so it's basically telling you, hey, it's going to have a consistent unit rate because it's a proportional relationship. So all you got to do is figure out the unit rate, and you multiply all those x values by that unit rate to get the corresponding y value. So I can use this one right here to figure out the unit rate. I can also use this one right here to figure out the unit rate. It's going to be the same. Either one works. I'm going to show you both. So y divided by x for the unit rate. Y is that distance, miles driven, so it's 54 miles. And then you consume 2 gallons of gas. Okay, to find the unit rate, we need 1 in the denominator. So we divided by 2, divided by 2. 54 divided by 2 is 27 miles. So 27 miles per gallon. So we multiplied that x value times 27. And look, it's going to work right here. The reason I didn't go, hey, let's use this one, is because there's no value for the miles driven there. So that's not enough information. But here, when they give you both values, you can totally figure out the unit rate. And it also tells you it's proportional. So I know for sure that this is going to be times 27. I already know that, okay? So y divided by x. So 216 miles. And gallons consumed was 8 gallons. Okay, to find the unit rate, we just find the unit rate. Divide by 8, divide by 8. Let's go 216 divided by 8. Up 27. 27 miles per gallon. So, yep, see that? So, to be consistent, you know you're going to take that x value and you're going to multiply by 27 every single time to get your corresponding y value. So 4 times 27, figure that out. 108. Oh, this one's backwards. So typically you take this number, times it by 27 to get 189, but to go backwards, you need to divide by 27. This 189 divided by 27. So when you do that, you should get 7. Okay? Wait, right? Let me check. 189 divided by 27 equals 7. Okay, just want to make sure. It looked weird to me for a moment. Okay, 10 times 27, that's 270. 12 times 27 is 324. Okay, so I think that's all we had to do. I do want you to write down the equation. It is a proportional relationship, so we can definitely write the equation out. It's going to be y equals 27 times x. That 27 is the unit rate, because they can go 27 miles on 1 gallon of gas. The y value, since you labeled it, see how I make you label it always? It helps you fill out your equation. Miles driven. And then the x, right there, is gallons consumed. I'm abbreviating it to gal consumed. Okay.